known to be present in 2% of the population. So we know that 2% of the population, they have the disease. A test is developed to help determine whether or not someone has a disease or not. Remember, one thing is having the disease in reality, and the other thing is some sort of a diagnostic test at the hospital which tells you whether you have the disease or not. Now, if the diagnostic test is correct, then maybe if someone has a disease, and the report might show that the person has a disease. In the other hand, the diagnostic test might be incorrect, and we know this happens in reality. So even if a person has the disease, the test might show that the person does not have the disease if it is incorrect. On the other hand, a person might not have the disease and the test might still show that person has disease if the test is again incorrect. So you have to understand, having a disease is one thing, and having a test that shows whether the person has a disease or not. So this is what this sum is all about. And we have information. It says, given that a person has a disease, if you know this information, then the test result is positive, is 95%. 0.95 means 95%. So that means if someone has a disease, the probability that the test result will say that the person has a disease, positive test result means positive with the disease, that is 95%. Obviously that means that's good. Given that the person does not have the disease, the test shows positive for 3%. 0.03 means 3%. So there is a 3% chance a person who does not have the disease for the diagnostic test to give an error report. So there is a 3% error chance here. So we have to draw a tree diagram. Now remember, I mentioned earlier, in case of tree diagram, the structure is option 1, option 2, and yes, no, yes, no. So option 1 is having the disease in reality. Option 2 is not having the disease in reality. Yes means the test at the hospital shows that the person has disease. No means that the test that the hospital shows that the person does not have disease, even though the person had disease in reality. So this is the branches, and this is how it works. So we can do this sum by having our tree diagram. So we have option 1, so let me call the option 1 disease, and option 2 not having the disease in reality. So disease is known to be present in 2% of the population. So the chance a person has the disease is 2%. That means 0.02. So the rule of probability is, if one of the probability is something, if you want to find the opposite of that, you do 1 minus that. So 2% is 0.02. So the probability of not having the disease is 1 minus 2%, means 98%. So this would be 0.98. 1 minus 0.02. So now we have the other two options: yes, no, yes, no. So positive, negative. Positive test result, negative test results. Okay, first of all, given that the person has the disease, so going through this branch, in reality the person has disease, so the test is positive, is 0.95 or 95%. So this branch would be 0.95. So automatically this would be 1 minus, because it's the opposite. 1 minus 0.95 is 0.05. Again, given that the person does not have the disease, this is this branch, the test is positive, so the positive test is still 0.03. So this would be negative, would be 1 minus 0.03, which means 97% or 0.97. So we are set with the tree diagram. Now the next question. So next question says, find the probability that the test is positive. We have to select a person. So how many ways can the test be positive? Test can be positive in one way, is the person has the disease and the test is positive. So it could be DP, or it could be the person does not have the disease in reality, but the test still shows that the person is positive test. So D prime P. So it would be D and P is 0.02 into 0.95, or D prime is 0.98 into 0.03. So the calculation would be 0.02 into 0.95 plus 0.98 into 0.03. So this is 0.0484, 0.0484. A doctor randomly selects a person from the population and tests for the disease given that the test is positive. Now remember the condition probability formula. The condition probability formula says probability of A given B is probability A intersection B divided by probability of B. So that's what we are going to use here. In question number C, it is given that the person has positive test results, so positive. So this is given, so positive. Now what we have to find the probability that he does not have the disease in reality. So does not have the disease means D prime. So this would be equals to, so positive. So we just found this out in the previous sum. So probability of being positive with the disease is 0.0484, and we need here that he does not have the disease in reality. That means A intersection B, so that would be D prime into P. So 0.98 times 0.03. So let's do the calculation here. So the calculation would be 0.98 multiplied by 0.03 is equals to this, 0.98 multiplied by 0.03. This is equals to this divided by 0.0484. So this would be 0.6074. That's pretty high. 0.6074. 0.6074. 0.6074 means 60.7%. So that means given that the test result is positive, the probability that he does not have the disease is 60%. That's a very high probability of a person where the hospital diagnostic report is saying he has the disease, but in reality he does not have the disease. That's a 60% chance. So that means the diagnostic reports are not very good. Anyway, let's do the next question. So the next question is comment on the usefulness of this test. So the test is not very useful. The test is not very useful since a person who does not have the disease has a high probability chance of a positive test result from the hospital. Positive test. So this question number D, it's not a question from a technical question or something. It is something, what do you think? You have to use your common sense. So there are many paper where we have 1 or 2 marks regarding this. You don't have to spend too much time solving this type of question. Just read the question and write it intuitively. So these are the type of questions that you don't have to write a perfect answer. Many answer would be correct here. Question number 5, this is obviously a Venn diagram sum because it mentions it here. You have to draw a Venn diagram. So let's do this instantly. So we have 3 ABC again as the previous paper. So we have 3 sets A, B, C. This is the universal set symbol. Okay, blood, we are talking about a person's blood group is determined by whether or not it contains any of the 3 substances ABC. This is just a story. A doctor surveyed 300 patients. Altogether we are talking about 300 patients blood and produced the table below. Only C. Now remember, when we say C, this is the entire set, but when they say only C, that means C that does not include A, does not include B. Only C is this region. So only C is 100. It is this region. Then we have A and C So A and C means this entire region, A and C, but not B. But not B means we have to remove B from A and C. So that means it will be only A and C is going to be this region. So that is 100. Only A. Again, only A is this. So this is 30. B and C. B and C is this entire region, but B and C, but not A. Only B and C. 25. It is going to be this one. Then we have only B. So only B is this region, which is 12. Then we have A, B and C, all intersection 10. So this region is 10. Then A and B. So A and B means this entire thing, but not C. So we have to remove C from there. So this would be 3. Now, so we have filled up the Venn diagram, but we just don't know this region yet. So this is going to be 300 minus this. So let's check 100, 100, 200. So 10, 30, 40, 43. Then we have 25 more. So let me use the calculator. 43 plus 25. This is going to be plus 12. Plus we have 200. This is 280. So it is going to be, so 300, from 300 if you remove 280, this would be 20. So draw a Venn diagram and the information is done. Next, Harry is one of the patients given that his blood contains substance A. So the information is given that he contains substance A. So the probability, this is going to be given, conditional is, we know A. Find the probability that he contains all three. So all three given A. So given A means this circle. So how many total here? So 100, 10, 30, so 40, 43, 143 is the total. This information is given. We have to pick from circle A. Now out of this, the question is all three. So out of this all three, this is only 10, all intersection. So 10 out of 143. Then the next one, I think this is question number C. Oh, there is another one, B. Let me do B here. Find the probability that a randomly chosen patient contains substance C. Okay, probability of C. Now the total is everything, 300. So out of 300, how many people has substance C? 100, 200, 235. Now let's do question number D, the final one here. Patients whose blood contains none of the substance are called universal donors. Find the probability that a randomly chosen patient is a universal donor. So this is 20, this region. So probability of universal donors, so there are 20 and altogether there are 300 people. So 20 out of this, we have to simplify it a little bit. So this will be 2 by 30. So this would be 1 by 15. Remember to simplify your answer. It's extremely important. The final question is a discrete probability distribution table, but it is a bit different because usually what we have is the probability given, but here we have the cumulative probability given. Let me review what a cumulative probability refers to. When we have F3, it refers to all the probability from the beginning up to 3. So if you have up to 3, usually you have 0, then 1, then 2, and then 3, all the way up to 3. So whenever we are talking about capital letter F, it refers to cumulative probability. So here what we have is not the probability distribution function or PDF, but the cumulative distribution function or CDF. So that means total. So whenever we put some value, that means total. So in this particular question, the random variables are 2, 3 and 4. So if I write F2, it means from the beginning up to 2. If I write F3, that means from the beginning up to 3. If I write F4, that means from the beginning up to 4. Okay, now we have to find the constant K. Now if I want to find the constant k, that means I have to find the total probability. So that means probability of 2 plus probability of 3 plus probability of 4. Total probability is always 1. Whatever the random variables are, if you add up the probability of all of the random variables, that is 100% probability, or total probability is 1. Now this can be written as probability of x is less than or equals to 4. Now we don't have 0 or 1, but we have 2, 3, 4. So x is less than or equals to 4 means all of the probabilities added together. But remember, this can also be written as a cumulative probability, f4. That means in x we can put 4, so x plus k means 4 plus k whole squared divided by 25 equals to 1. Therefore 4 plus k whole squared equals to 25. That means therefore 4 plus k equals to plus minus square root of 25, which is plus minus 5. So we have 4 plus k equals to plus 5, k equals to 5 minus 4 equals to 1. Since k is a positive integer, this is our answer. We don't even have to do the sum with minus 5 because that will be negative. So the answer is k equals to 1. Now we have to find the table. So the table is going to be like this. So we have the random variable here, and the random variable is only, we have 2 here, we have 3 here, we have 4 here. So probability of x equals to x. So we do not have any PDF here to find the random variable, so we have to find the PDF from the CDF. Now if you remember that probability of something, suppose you want to find the probability of x equals to 3, you can find it by subtracting the cumulative probability from the previous cumulative probability. This happens because f3 represents from the beginning 0, 1, 2, 3 up to 3, and f2 represents from the beginning up to 2. Now if you subtract this from this and this cancel, this and this cancel, this and this cancel, only this remains. So this would be probability of this. So from that we can get a general idea that probability of something, suppose probability of a, it is fa minus fa minus 1, the previous one. So that's how this works. So let's try to find out the probabilities of the cumulative probabilities of each and every one of them. First of all, we know that f4 let me write out the CDF here. F x equals to x plus k, k is 1 squared divided by 25. Okay, so first of all we know f4 is 1 because total probability is 1. Then f3 is going to be 3 plus 1, 4 squared is 16 by 25, and f2 is going to be 2 plus 1, 3 squared is 9 by 25. Okay, now for finding this p2, so for finding p2 we know it is going to be f2 minus f1, meaning the previous one. So here for p2, f2 is 9 by 25 minus the previous one, but there is no random variable before it, there is no 1. So this means 9 by 25 minus nothing, so this would be 9 by 25. p3 is going to be f3 minus f2. Okay, so f3 we know is 16 by 25 minus f2 is 9 by 25. So this is going to be 9 by 25. f3 is 16 by 25 minus 9 by 25. So this is going to be 16 minus 9 is going to be 7. So this will be 7 by 25. Finally this is 4. So p4 is going to be f4 minus the previous, which is f3. So we know f4 is 1 and f3 is 16 by 25. So 1 minus 16